Good morning. In this video, we're going to show similarity on triangles and congruence on triangles. The first example here will illustrate to us uh, two triangles that are similar. Okay, let's analyze the given. DE here is parallel to AC. So DE is parallel to AC, and what does that imply? For that one given, we know that the corresponding angles are congruent. This is congruent to this, and this also is congruent to that, but we may not need that. We just say that this angle is congruent to itself. So in fact, we have two triangles here. We have triangle DBE and triangle ABC. And here, DE here is parallel to DE. Okay, so let's have our proof. The first column will be the statements, and the next column will be the reasons. Okay, so always start with what the given tries to tell us. So here, DE is parallel to AC. That's given. And the implication of that is that angle BDE is congruent to angle BAC. BDE, BAC. Because we have two parallel lines, therefore the corresponding angles are congruent. So, parallel there and corresponding angles are congruent. And then number three, I can just say that angle B is congruent to itself, angle B. So this is what? Reflexivity. Reflexivity. Okay, and number four, I can now say that triangle BDE is similar to triangle BAC. This is by what? AA corollary. AA corollary. So what did we actually do there? If these two triangles are similar, then the corresponding parts should be proportional. So we have here what? BD is to BA as BE is to BC as DE is to AC. Did I get that right? BD is to BA, BE is to BC, and DE is to AC. This is definition of similar triangles. Okay. Now, what do I need here? I need this cross product here that contains A, B, and BE. So, A, B, and BE, this one here, this pair here will contain that. And I can just apply MPE, and I will get what? BA times BE equals BD times BC. This is MPE. That's what we wanted to prove. That this ratio here and this ratio is a proportionality, and we just had to cross multiply to get this desired form. So BA times BE is equal to BD times BC. So what did we actually do here? This one gave us what we wanted, that it has so many implications that when we say DE is parallel to AC, then corresponding angles are congruent. Okay, those are congruent. But we did not need to have these two angles congruent because we already have this and B itself for us to have AA corollary. Okay, so that's how we do number one. Let's take a look at number two. Number two here, uh, if we have AB parallel to DC, AB, segment AB congruent segment DC, and C is the midpoint, then what we can probably do here is to analyze again. Again, we will want to analyze what is the given. here, AB here is parallel to DC. So what is the implication? This one serves as the transversal, and we can say this angle should be congruent to this angle because they are corresponding angles. Okay, let's name this angle 1 and this is angle 2. That's the implication of that parallelism there. And then AB is congruent to DC. AB, segment AB here is already congruent to segment DC. So we have now a side angle and we want to find out if it is ASA or SAS. We don't know anything about the relationship of angle D and angle D, angle A and angle D, I mean. So we cannot proceed that direction. We need to find what happens here. And the next given tells us C is the midpoint of DE. Therefore, this should be congruent to that. And from that analysis, we can say that triangle ABC is congruent to triangle DEC by SAS. But that's not what we want to prove. We want to prove that AC here, I will write that in another ink. Here, AC, uh, we want to show that this is parallel to that. The only way to show that will be to have two angles congruent. We want to show that these angles here are congruent. And if they are, then this will become the corresponding angles that will be congruent, and we can conclude that AC is parallel to DE. Okay, let's write the statements now. Okay, statements and the reasons. Number one, we will always have to start with the given. AB parallel to DC. This is given. Now, what is the implication of that? Since AB is parallel to DC, I say this angle 1 here, I named it as angle 1, is congruent to angle 2. Remember, we have parallel first, parallel, and then the corresponding angle should be congruent. It's not CAP, it's PCA. And what else do we know? The other given is what? So we have here angle here. And then we have AB is, segment AB is congruent to segment DC, that is also given. So we have a side here already. Okay, we have a side there. And then the next given is that C is the midpoint of segment BE. That one is given. Now, what is the implication of that given? That C here is splits BE into two congruent segments. So BC is congruent to EC. Okay, this is definition of midpoint. Okay, BC is congruent to CE or EC. Now we can say that triangle A, look at the correspondence. ABC is congruent to triangle DEC, not DCE, it's DEC. This one corresponds to uh, this one here. Uh, ABC, no, it should be DCE. It should be DCE. Okay? Triangle ABC is congruent to triangle DCE by SAS postulate. Okay? And then, number 7 here, I will name this angle 3, and then this is angle 4. So, that angle there, angle 3 there, is congruent to angle 4, or that is ACB. ACB and DEC. This is corresponding parts of congruent triangles are congruent. And if they are, we can now say that AC is parallel to DE. What would be the reason? We were able to find two corresponding angles that are congruent, hence they are parallel. Okay, I want to emphasize that. This is PCA and this is CAP. Here we are trying to prove that the lines are parallel. So we found two congruent angles, corresponding angles. Then we said they are parallel. Here we are given that they are parallel. So we have parallel and then we can say that the corresponding angles are congruent. Okay? So there you go for uh, that number. Uh, let's see the last number there. Okay, so we have uh, angle again. The thing that you do is you're going to pre-analyze the problem. Okay, I want to draw the triangle separately so you can see it better. So I have here uh, triangle A, B, D, and then we have here triangle, not very good, A, C, D. And let's try to find out what is given. Okay. B angle BAD, this one here, is congruent to what? Angle CDA. Where is CDA? CDA here. That's congruent. And we know that AD here is the same. So this one here is congruent to AD here by reflexivity. Now, is this going to be an SAS or ASA? We don't know angle 1 here and angle 2, we don't know what they are. Okay, so we probably would go to this side. AB, now that's given. AB here is congruent to CD. So we have now the ingredients of two triangles congruent. So that's how we are going to prove with, now to prove, to reason out. Okay, so let's start our proof. Statements here and then the reason here. Uh, Number one, what is given? Angle BAD is congruent to angle CDA. This is given. And then we go on and say AD is congruent to itself. This is reflexivity, reflexive property of equality or congruence. Number three, we are given also that AB is congruent to CD. This is given. With all these ones here, we can now say the triangle BAD is congruent to triangle CDA by side angle side postulate. Okay? Now, what do we intend to do here? We want to show here that AE here, this one here, is congruent to triangle, to segment ED here, ED. Note that we have many ways how to get to this one, but all of them will want us to prove that this triangle, let's say, I will say this triangle A here, which is ABE, should be congruent to triangle B here, which is what? BCE. And if we show that triangle A and triangle B here are congruent, we can just state that AE is congruent to ED by CPCTC. Okay? So what do we know of that triangle? What do we know of the triangle A and triangle B? Okay, let's erase this one and then concentrate here now. I know that in our purpose now is to show that triangle ABE is congruent to triangle CDE. Okay, now from the given, I know that this is congruent to that. That's here, up here, ABCD. Then I also know that angle B is congruent to angle C. So it's not there, so I will write it. Angle B is congruent to angle C. Why is that? Because they are corresponding parts of the big triangles. Angle B here is congruent to angle C here. So I can say CPCTC. Now I have assigned an angle. And I can see that I have another angle here that can be congruent. Let's say angle 3 here and angle 4. What are they? Number 6, angle 3 and angle 4 are vertical. Okay? Definition of vertical angles. Vertical angles. And then if they are vertical, then they must be congruent. Okay? This is the vertical angle theorem. So if we have shown that this is congruent to this, I can now say that number 8 here, triangle ABE is congruent to triangle uh, ABE is D uh, ABE DCE. This should be DCE. DCE. ABE DCE. That is, I already have SAA. So this is an example of SAA theorem. Okay, where the two triangles are congruent now by side angle angle. And I can now say that number 9 there is what? Segment AE is congruent to segment EB. Segment AE here now is congruent to segment CD by CPC TC. Okay, so what did we actually do here? We tried to prove two triangles congruent, okay, and then went on to find out another two triangles that can be proven congruent, okay, from the given. Okay, so that's it.